Uranus was the first planet to be discovered with the aid of a telescope, expanding the known boundary of the solar system in a single human lifetime. For thousands of years, the farthest wandering star that people could track with the naked eye was Saturn, a limit that felt permanent simply because it was all our eyes could reach. The night sky was a familiar map, with planets moving in predictable paths among the constellations. But in 1781, in Bath, England, William Herschel noticed a strange object that refused to behave like an ordinary star. Through his reflector telescope, it showed a tiny disk rather than a sharp point of light. He first suspected a comet, but further work revealed something far larger and more profound. A new planet, the first one found beyond Saturn, and the first discovered in the modern age. In that single observation, the universe quietly widened, reminding us that the sky can hold hidden giants for centuries, waiting until we learn how to look properly. The planet we now call Uranus almost carried the name of a British king, a reminder that discoveries begin in human worlds before they become universal. After Herschel's discovery, he proposed Georgium Sidus, or George's star, honoring King George III. For a brief period, the new world was tethered to a single nation's politics, as if a planet could belong to a patron. But astronomers wanted a name that would outlive reigns and borders and fit the mythic rhythm of the solar system. The name Uranus, Oranos, the Greek sky deity and the father of Saturn, slowly became the accepted choice, lifting the planet out of politics and into a timeless family tree of gods. The sky kept its ancient language, and the ice giant found a name that would not expire. Uranus orbits the Sun at such a tremendous distance that the warmth we feel on Earth becomes a faint, distant memory. This ice giant drifts at an average distance of roughly 2.9 billion kilometers from the star that anchors us all. To stand on its cloud tops would be to see the Sun not as a blazing disk, but as a bright, piercing point of light in an enormous darkness. Even light itself takes time to cross that gulf, more than 2.5 hours to reach Uranus from the Sun, so the planet lives in a delayed glow, a twilight delivered late. Out there, the Sun's gravitational hold is gentler and stretched thinner, and the whole system feels quieter, slower, more spacious, as if the solar family has room to breathe. Because of its immense distance, a single year on Uranus lasts 84 Earth years. It is the kind of orbit that makes time feel like geology rather than calendar. A child could be born, grow up, and grow old before Uranus returns to the same place in its path. The seasons there are not quick moods that pass in months. They are long regimes of light and shadow that last decades, allowing the atmosphere to settle into patterns that take a human lifetime to unfold. Uranus does not rush through its year. It drifts through it, a slow rolling world making its long circuit around a distant sun. Uranus holds a unique distinction among planets. It rotates on its side, rolling through space like a pale blue wheel. Its axial tilt is about 98 degrees, meaning the planet's north pole points almost where other planets would place their equator. This posture suggests a chaotic past. Many scientists have imagined a colossal ancient impact, something Earth-sized, knocking Uranus over long ago. Others propose slower, gentler tipping mechanisms involving gravity and resonance over millions of years. Whatever the cause, the result is unforgettable. A planet permanently laid sideways, carrying the scar of its history in the direction it spins. This extreme tilt creates seasons that feel less like weather and more like eras of light. Near solstice, One hemisphere can face the sun for years at a time, while the other sinks into a long polar night. Over the course of Uranus's long orbit, the poles trade these roles, decades of daylight exchanged for decades of darkness. During equinoxes, the pattern becomes more familiar for a while, with day and night cycling across the globe, but the overall rhythm remains strange and profound. Uranus teaches that day and night are not universal experiences. They are local customs of a planet's posture in space. Despite its massive size, Uranus is an ice giant with a surprisingly low density, so low that it is only slightly denser than water. If you could place it in a cosmic ocean large enough to hold it, it would sink, but slowly, like a giant world that is buoyant in its own way. This low density tells us what it is made of. Not heavy rock like Earth, but a deep interior dominated by ices in the planetary science sense, water, ammonia, and methane, compressed into hot, dense fluid layers. It is a planet that looks like air and ice from afar, yet hides a heavy, pressurized interior beyond imagination. Even Uranus's gravity is gentler than many people expect. At the level we call the cloud tops, gravity is slightly weaker than Earth's, about 0.9 g. It is a strange, comforting echo across billions of kilometers. A world so huge, yet the pull you would feel is not crushing, just lighter. Of course, there is no solid surface to stand on, only deeper and deeper layers, but the simple number is still surprising. Uranus is a giant, but it holds you with a softer hand than you might imagine. Uranus wears a smooth, pale cyan color that looks almost unreal, as if someone painted a planet with a single calm shade. The atmosphere is mostly hydrogen and helium, but methane in the upper layers absorbs red light and leaves more blue-green light to reflect back into space. Yet the color is not just chemistry, it is also haze. Uranus tends to have a thicker, more stagnant aerosol haze than Neptune, which softens its color into a milkier pastel and makes the planet look calmer and more uniform. In a sense, its very appearance is a mask made of cold smog and tiny particles, a veil that hides deeper layers and turns turbulence into serenity. Uranus is often called the coldest planet in the solar system, with a minimum atmospheric temperature around 49 Kelvin, which is about minus 224 degrees Celsius. That is cold enough to make familiar gases behave differently, and cold enough that the sky itself feels like a freezer turned to its deepest setting. For a long time, Uranus was treated as the odd giant that gave off almost no internal heat, as if it had somehow gone thermally quiet. Newer research has revised that picture. Uranus does emit more energy than it receives from the Sun, on the order of about 15% more, still far less than Neptune, but enough to show it is not completely switched off inside. Uranus remains the quietest of the giants, yet its quietness is not absolute. Even with that calm reputation, Uranus can be a windy world. Wind speeds can reach about 560 miles per hour, roughly 900 kilometers per hour. The flow pattern is also strange. At the equator, winds can blow retrograde, opposite the planet's rotation, while closer to the poles they shift to a prograde direction, moving with the spin. The planet may look smooth, but the air is not motionless. Invisible rivers of gas sweep around the globe in silence, carving patterns we only notice when sunlight and haze allow the clouds to reveal themselves. High above the cold cloud tops, Uranus hides another paradox. Its upper atmosphere can be extremely hot. Measurements and models place the thermosphere at temperatures around 800 to 850 Kelvin, far hotter than simple sunlight would predict at such distance. Scientists have debated what heats it. Atmospheric waves, interactions with the solar wind, and auroral processes are all candidates. But no single explanation fully settles the question. It is a hidden warmth wrapped around a frozen world, a reminder that even a planet famous for cold can wear a hot crown of thin gas far above its blue face. Uranus has a smell story too, one that is funny but scientifically important. In 2018, researchers detected hydrogen sulfide gas above Uranus's main cloud deck, a chemical associated with the smell of rotten eggs. The point isn't the joke, it's what it means. It suggests that Uranus's upper cloud deck is likely dominated by hydrogen sulfide ice rather than ammonia, helping distinguish the ice giants from Jupiter and Saturn in composition and formation history. Uranus's calm color can hide surprisingly sharp chemistry. Even a pale planet can be full of strong ingredients. Uranus is surrounded by 13 faint rings and a large family of moons, 28 known moons as of NASA's current count. Its satellites are sometimes called the literary moons because many are named after characters from Shakespeare and Alexander Pope, giving the system a strange theatrical poetry. Rings and moons circle in the planet's tilted plane like a stage set turned on its side, performing their slow, silent play in the dark. Uranus is not just one planet. It is a whole tilted system, a pale world with a charcoal halo and a cast of icy characters. There is also a new refinement to something as basic as time, the length of a Uranian day. For decades, the best estimate came from Voyager-era measurements, but a more recent analysis using years of Hubble observations of Uranus's aurorae refined the rotation period to about 17 hours, 14 minutes, and 52 seconds, slightly longer than earlier values. Even a planet can keep a secret about how fast it turns until we watch it carefully for long enough. Uranus reminds us that knowledge is not always about discovering something new. Sometimes it is about measuring the old truth more precisely. The Epsilon ring is the brightest and most substantial strand in that halo, and it behaves like a living ribbon rather than a uniform band. Its width changes along its orbit, becoming narrower in one region and wider in another, as if the ring breathes as it circles. Two small moons, Cordelia and Ophelia, orbit on either side of it like quiet guardians, using their gravity to herd ring material back into place when it drifts. Without these shepherds, the ring would slowly spread and fade, dissolving into a thinner haze over time. In the Uranian system, even tiny moons can hold large structures together, simply by being patient and repetitive. Uranus's sideways posture makes the rings even more theatrical. Because the planet is tilted, our viewing angle changes dramatically as it moves along its long orbit, and twice per Uranian year we see the rings nearly edge on. In those moments, called ring plane crossings, the rings can seem to disappear entirely because they are so thin. One such crossing occurred in 2007, and it created a rare window. With the rings turned edge on, astronomers could more easily spot faint moons and dusty features normally lost in the glare of the ring plane. Uranus reminds us that sometimes the universe doesn't change at all, only the angle from which we are allowed to see it. Beyond the main narrow rings, Uranus also has quieter structures that feel like drifting dust rather than solid bands. Some outer rings are broad and extremely faint, and one is closely tied to the tiny moon Mab, which feeds it with fresh dust as micrometeoroids strike the moon's surface. This creates a delicate cycle. Small impacts create dust. Dust becomes a ring, and the ring slowly thins unless the moon keeps replenishing it. It is destruction turned into structure, a soft, continuous recycling that paints a faint line around a distant planet. If the rings are Uranus's dark jewelry, its magnetic field is its strangest invisible signature. Uranus has a strong magnetic field, but it is tilted dramatically, about 60 degrees away from the planet's rotation axis, and it is also offset from the planet's center by roughly a third of its radius. This misalignment makes the magnetosphere behave in a way that feels almost alive. As Uranus rotates, the whole magnetic structure changes orientation, shifting and wobbling through space, interacting with the solar wind in patterns that can be wildly different from hour to hour. One of the most striking consequences of this geometry is that Uranus's magnetosphere can behave like a switch. Research based on Voyager-era measurements and later modeling suggests that as Uranus rotates, the magnetosphere can alternate between configurations that are more open to the solar wind and configurations that are more closed, as if the planet is repeatedly opening and shutting a door in space once every Uranian day. It is a daily rhythm of exposure and shielding, a kind of magnetic breathing that links the distant ice giant directly to the sun's invisible particle wind. This twisted magnetic arrangement also helps explain a famous moment of confusion during exploration. Before Voyager 2 arrived, Uranus seemed strangely quiet in radio emissions compared with other giant planets. The planet was not truly silent. It was simply beaming its signals in directions that didn't line up well with Earth at the time, thanks to that tilted and offset magnetic field. Uranus can be loud and active, yet still sound quiet from where we stand, not because the music isn't playing, but because we are not in the path of the broadcast. Uranus has even been detected in X-rays, a faint glow that feels surprising for such a cold and distant world. Observations from the Chandra X-ray Observatory showed that Uranus and its rings can produce X-rays, mainly by scattering solar X-rays, with hints that some X-ray activity could also be linked to auroral processes. It is a reminder that planets can glow in many kinds of light we cannot see, carrying energy signatures that exist beyond human senses. Uranus may look calm in visible light, but in other wavelengths it can still whisper. The moons of Uranus form a literary chorus in the dark, named not after Greek gods like so many other moons, but after characters from Shakespeare and Alexander Pope. There are 28 known moons, ranging from tiny inner satellites that orbit in crowded traffic to major moons that are large enough to carry deep canyons and ancient scars. The naming tradition gives the system a strange poetry: Oberon, Titania, Ariel, Umbriel, Miranda, like a frozen stage where characters circle endlessly, performing an orbital play that never ends. Miranda is the moon that looks like it was assembled from broken pieces, a patchwork of mismatched terrains stitched together in ice. Its surface is chaotic, bands of ridges, strange ovoid regions, and abrupt changes in texture that make it feel like several worlds forced into one. One idea is that Miranda was heavily disrupted long ago, perhaps shattered and reassembled, or repeatedly stressed by gravitational resonances that heated its interior and fractured its crust. It carries the feeling of a moon that has survived trauma, a frozen record of an older, more violent time. On Miranda, one feature has become almost legendary: Verona Rupes, a towering cliff that may be among the highest known in the solar system. Estimates vary, but the scarp is often described as potentially around 20 kilometers high, and even if the true height is lower, the idea remains astonishing. In Miranda's weak gravity, a fall from such a cliff would take many minutes, long enough that it becomes less like a plummet and more like a slow drift through cold darkness. It is one of those places that makes the solar system feel unreal. A cliff taller than mountains, on a moon that looks like it was cracked and stitched back together. Ariel is the bright one, often described as the most reflective of Uranus's major moons, and its surface hints at a history that was more active than it looks at first glance. It carries valleys, long trench-like features, and smooth areas that appear to have resurfaced the moon more recently than the heaviest cratered worlds. The patterns suggest stretching, cracking, and possibly flows of icy material that softened older scars. Ariel feels like a moon that once moved more, warmed more, and reshaped itself more recently than its darker siblings, leaving behind a cleaner, calmer face. Umbriel is the shadow twin, the darkest of the major moons, and it looks like a world that rarely healed. Its surface is heavily cratered and ancient, a place where impacts left marks that were not erased by later activity. And yet, Umbriel holds one haunting exception, the Wunder crater, which contains a mysterious bright ring of material on its floor. This bright Cheerio sits near Umbriel's equator, stark against the moon's dark skin, and its origin is still debated. Fresh impact material, or even deposits like carbon dioxide frost trapped in a cold basin. Umbriel is a moon that keeps most of its light hidden, and then, in one place, offers a single luminous circle as if it were a clue. Titania is the largest of Uranus's moons, and it carries the signs of a world that expanded and cracked as it cooled. Large canyon systems and fault lines cut across its surface, suggesting that internal changes, freezing, shifting, and possible ancient internal oceans stressed the crust until it split. Titania's scars feel like the lines in old ice, evidence that even in the outer solar system, moons can have internal histories that evolve, cool, and rupture the surface from within. It is a large, quiet queen of the Uranian system, holding ancient fractures like wrinkles that never smoothed out. Oberon, the outermost of the major moons, feels like the oldest sentinel. Its surface is heavily cratered and less obviously resurfaced than some of its neighbors, preserving a long record of impacts. Some craters have dark floors, hinting at material from below or ancient deposits that pooled after impacts. Oberon's distance also means it spends more time exposed to space weathering and the solar wind compared with the moons deeper inside the system. It is a relic world, a cold archive of collisions, holding history the way stone holds fossils. Closer in, Uranus's inner moons crowd together in a tight region that is not perfectly stable forever. The Portia group, an unusually packed cluster of small moons, shares space so closely that gravitational nudges can slowly push orbits toward overlap over long time. Simulations suggest that collisions among some of these moons are likely on million to 10 million year timescales, with impacts producing fresh debris that could feed future rings. This makes Uranus's system feel alive on deep time. Moons collide, rings form, rings fade, moons reaccrete. The calm blue planet is surrounded by a region where creation and destruction quietly trade places. Far beyond the major moons, Uranus also hosts irregular satellites, captured objects on tilted, often retrograde orbits, like dark strangers that never truly belonged to the original family. Sycorax is the largest of these irregular moons, a distant world likely captured long ago and marked by the reddish tint of radiation-processed material. Caliban and Setebos orbit as other small, dark captives, named like characters in a colder, stranger part of the same literary play. And then there is Margaret, unusual among Uranus's irregular moons because it orbits in a prograde direction despite its tilted, eccentric path. A reminder that capture can produce many outcomes, and that even outsiders can have their own exceptions. Even Uranus's orbit can briefly host companions that are not moons at all, but temporary escorts. A Trojan asteroid, 2011 QF99, was found sharing Uranus's orbit in a stable gravitational pocket, though only for a limited time on astronomical scales, likely hundreds of thousands of years rather than forever. It is a traveler caught in Uranus's rhythm, following along like a quiet companion for a short chapter, before drifting away again. Uranus's path through space is not always lonely. Sometimes gravity gives it a temporary shadow that walks beside it. Humanity has only visited Uranus once, and that single encounter still shapes nearly everything we know from direct measurements. In January 1986, Voyager 2 swept past the planet and its moons, discovering new inner moons, photographing the ring system, and revealing a magnetic field that nobody expected to be so tilted and offset. The flyby was brief, one quick pass through a tilted kingdom, but it turned Uranus from a smooth disk in telescopes into a world with structure, scars, rings, and an invisible magnetic life. And then it moved on, leaving Uranus to return to its quiet, rolling journey in the dark. When Voyager 2 arrived at Uranus in January 1986, it met a planet that looked almost disappointingly calm. In the images, Uranus appeared like a pale aquamarine bead, smooth, quiet, almost blank, so different from the striped drama of Jupiter or the golden turbulence of Saturn. That calmness helped give Uranus its boring reputation for years, as if the planet were asleep. But the timing mattered. Voyager's visit happened near a Uranian solstice, when one pole was turned toward the Sun and seasonal circulation patterns were arranged in a way that can make the atmosphere look more stable and uniform from our viewpoint. Uranus didn't become interesting later. It simply revealed its interest only when the season and the angle were right. In the decades since that flyby, Uranus has slowly peeled back its mask. Modern telescopes have seen bright storms flare up in its atmosphere, sometimes large enough to be noticed even by skilled amateur observers with the right equipment. These storms can glow in infrared light like embers in the cold, rising from deeper layers and condensing methane into bright cloud tops. Uranus is still quieter than Neptune, but it is not motionless. Its calm face is not a guarantee of calm weather. It is a veil, and behind the veil, the sky is always doing something, even if it does it slowly. For several years, astronomers tracked a long-lived Uranian feature nicknamed the Berg because it drifted like an iceberg through the atmosphere. It was not a single fixed storm so much as a persistent, evolving system that lasted for years, brightening and shifting as it migrated. Observations suggested it lingered at southern latitudes for decades, then began moving toward the equator in the mid-2000s and eventually broke apart, as if the planet finally exhaled and let it dissolve into smaller clouds. It was one of the clearest proofs that Uranus can sustain large-scale weather features for long stretches of time, not in a frantic rush, but in a patient, gliding endurance. Uranus also wears a seasonal cap of haze that can brighten and fade like a slow breath. Astronomers call it the northern polar hood, a bright, cap-like feature that sits over the North Polar region. Over the years, observations have shown it changing and brightening, as if the long seasons are gradually repainting the planet from the top down. In a world where sunlight is faint and seasons last decades, even a subtle change in haze can be a major climate event. Uranus doesn't shout its seasons, it whispers them, slowly, through the tone and brightness of its polar veil. The rings, too, have their own hidden surprises, especially in the faint dusty belts beyond the main dark bands. Uranus has outer dust rings that are so delicate they are best revealed when viewed in forward scattered light, when sunlight passes through the dust and the particles glow like mist. One of these dusty rings has been described as unusually blue, a rare trait for planetary rings, and that blueness hints at extremely tiny grains that scatter light in a different way. Another dusty ring appears slightly redder, closer to the more typical color of ring dust elsewhere. Even Uranus's rings have a palette, faint, subtle, and only visible to the most patient instruments. During the 2007 ring plane crossing, the geometry of the system gave astronomers a rare kind of clarity. With the rings seen edge-on, much of their glare faded, and faint structures became easier to detect. In that era, some of the planet's dim dust components stood out more strongly, and the ring system briefly felt less like a set of sharp hoops and more like a complex disk with hidden layers. Uranus teaches a gentle lesson about vision. Sometimes the universe doesn't change at all. Only the angle of our sight does, and suddenly, what was invisible becomes obvious. The family of Uranus's small inner moons also continues to grow, and recently it grew in a way that feels wonderfully fitting for a planet famous for hiding in plain sight. For a long time, Uranus was said to have 28 known moons. Then, in 2025, observations with the James Webb Space Telescope revealed a tiny new moon, designated S/2025U1, only about 10 kilometers across. It had been missed for decades because it is faint, small, and lost in the clutter near the rings. With that discovery, Uranus's known moon count rose to 29, a quiet reminder that even now, the solar system can still add a new character to an old cast. Some moons were hidden not by distance, but by the simple fact that we didn't notice them in time. Perdita is the perfect example, a moon whose name means lost. It appeared in Voyager 2 images, but it wasn't recognized until years later when scientists re-examined old data with sharper attention. That story carries a soft moral. Discovery is not always about new observations. Sometimes it is about seeing what was already recorded and realizing a faint dot was never just noise. Other tiny moons like Cupid and Mab were discovered in the modern era with space telescopes rather than spacecraft flybys, proving that Uranus's system is crowded with small bodies that are easy to overlook. These moons live close to the rings and close to one another, in an orbital traffic zone that is not perfectly stable forever. Over very long times, gravitational nudges can slowly amplify, pushing some orbits toward crossing and making collisions likely on million to 10 million year timescales. Uranus's inner system is like a slow-motion pinball machine, quiet in the moment, but dynamic in deep time. One day, impacts could create fresh dust, and fresh dust could become fresh rings, a new halo born from old moon fragments. Uranus is not only a planet of discoveries, It is also a planet that helped us discover the next world. After Uranus was found and its orbit could be tracked precisely, astronomers noticed that it did not move exactly as Newton's equations predicted. It sped up and slowed down slightly, as if something unseen were tugging on it from farther out. That orbital misbehavior became the clue that led to Neptune's prediction and discovery. Uranus, by drifting off its expected path, became a messenger, a planet that told us the solar system was not finished and that another giant waited beyond the darkness. Uranus even left its mark on language down here on Earth in a way that feels almost poetic. In 1789, when the chemist Martin Klaproth discovered a new element, he named it uranium, honoring the newly discovered planet and the sudden expansion of the solar system. This means that one cold, distant world became permanently linked to one of the most powerful elements humans would ever learn to use. It is a strange bridge between extremes, a frozen planet far from the sun, and a heavy element that can release enormous energy. The naming is a reminder that the sky and the laboratory are connected by more than curiosity. They are connected by the human habit of weaving discoveries into our words. And the man who discovered Uranus carried his own quiet poetry. William Herschel was a musician before he became a famous astronomer, a composer and conductor who spent his days with harmony and rhythm. Then, at night, he ground mirrors and searched the heavens with a patience that feels almost musical. It is fitting that someone trained to hear patterns was also the one to see a pattern break in the sky, a star that wasn't a star, a point that became a disk. Uranus was discovered by a mind used to listening for subtle differences, and that discovery widened the world for everyone who came after. Today, Uranus stands as one of the great unfinished stories of planetary science. We have only visited once, and that single flyby left behind a long list of questions. Why the planet's interior heat is so modest compared to Neptune's, how its tilted and offset magnetic field truly works, how its rings evolve, and how its moons are shaped by both gentle tides and future collisions. That is why a return to Uranus has become a serious priority for exploration. Mission concepts envision an orbiter that could watch the planet for years and a probe that could fall through the atmosphere, tasting its gases and measuring its chemistry directly. Uranus is not only a beautiful oddity, it is a missing chapter in how ice giants form and evolve. Uranus is a world that teaches patience. It rolls on its side through an 84-year year, trading decades of daylight for decades of night. It hides storms behind haze, hides rings in darkness, hides moons in the glare of dust. It looks calm until it isn't, and it looks empty until a sharper eye finds one more speck circling near the rings. Uranus reminds us that the universe does not reveal itself all at once. Sometimes it reveals itself slowly, over years, over decades, over generations, as our tools improve and our attention deepens. Uranus is so distant that its light is never truly bright, even at noon, and that changes the mood of everything you imagine there. The sun would still be the brightest object in the sky, but its warmth would feel like a rumor, and its light would seem thin and cold. The shadows would look crisp, not because the sun is strong, but because the air is clear of the thick, warm haze we are used to on Earth. In such a place, day and night would not feel like the warm rise and fall we know. They would feel like a subtle shift in a pale gloom, as if the planet is always halfway between waking and sleeping. The distance also means Uranus lives inside a slower conversation with the Sun. Solar storms that sweep past Earth in days reach Uranus later, and their effects can linger differently because the planet's magnetosphere is so strangely tilted. From far away, you might think Uranus is quiet and untouched, but in reality, it is constantly interacting with the solar wind, just on a scale of time that feels stretched, softened, and delayed. The outer solar system is not only colder, it is slower, like music played at half speed, where every note hangs longer in the air. Uranus's atmosphere is mostly hydrogen and helium, like the other giant planets, but the small fractions matter more than you'd guess. Methane gives the planet its blue-green tone by absorbing red light. Hydrogen sulfide, detected above the main cloud deck, hints that the upper clouds may be made of hydrogen sulfide ice, rather than the ammonia clouds we associate with Jupiter and Saturn. In that sense, Uranus is not simply a smaller Jupiter. It is a different category of giant, with different cloud chemistry and a different story of formation, written into what condenses where in the sky. The planet's clouds are layered like an upside-down ocean. What you see as a calm cyan face is only the uppermost layer of a deep, structured atmosphere. Below the methane and haze, there are likely deeper cloud decks where other substances condense, and below those, pressure and temperature rise steadily until the idea of cloud becomes meaningless. Uranus does not have one weather layer. It has a vertical world of pressures stacked like depths in water. The surface is not a place. The surface is a range of conditions, and the deeper you go, the more the planet stops behaving like a sky and starts behaving like a hot, dense sea. Because Uranus is so cold, many processes that drive dramatic visible weather on Jupiter are muted here. Ammonia clouds, for example, do not sit high and bright in the upper atmosphere the way they do on the gas giants. The cold sorts materials by freezing and sinking, leaving the upper layers comparatively cleaner and calmer in appearance. That is one reason Uranus can look featureless in visible light. The planet is not empty of motion. It is simply wrapped in a haze that smooths its face, like frosted glass that turns sharp detail into soft color. Even that smoothness changes with season, but it changes the way a glacier changes, not the way a summer storm changes. When Uranus moves toward equinox, sunlight returns to regions that have been in darkness for decades, and the atmospheric circulation can shift. Haze can thicken, clouds can brighten, and storms can flare in places that once looked quiet. Uranus does not switch from calm to active overnight. It drifts into activity like a slow awakening, as if the planet needs years to remember what sunlight feels like. There is a subtle irony in Uranus's seasons. The poles receive decades of continuous sunlight at solstice, and yet the planet does not respond in the simple way our instincts expect. The equator can appear warmer than the poles, even when the poles have been favored in sunlight over long timescales. Heat transport, circulation, and stored energy likely play a role, but the full explanation remains uncertain. Uranus is a reminder that on other worlds, the sun does not always write temperature patterns in a straightforward script. Sometimes the atmosphere edits the script, moving warmth in hidden currents and rewriting where the cold truly settles. Wind on Uranus is powerful, and it behaves like a set of invisible rivers. At the equator, winds can blow in the retrograde direction, opposite the planet's rotation, while nearer the poles, the flow becomes prograde. This means the planet's atmosphere does not simply ride along with the spin. It has its own logic, its own balance of momentum, sunlight, and internal structure. The sky is moving even when it looks still. Uranus teaches that calm appearance is not the same thing as calm physics. The strangest heat on Uranus may live where you would least expect it, high above the clouds, in the thin upper atmosphere. Despite weak sunlight, Uranus's thermosphere can be extremely hot, hundreds of degrees Celsius, far more than sunlight alone should provide. This is one of the planet's long-standing mysteries. Energy may be delivered upward by waves from below, or injected by solar wind interactions, or shaped by auroral processes and magnetospheric dynamics. Uranus is a world where the coldest planet can still wear a hot crown, hidden high above the visible face. Because Uranus's magnetic field is tilted and offset, its auroras are not neat polar curtains like Earth's. The geometry is awkward, and the interactions with the solar wind can be complex. Auroral emissions exist mostly in ultraviolet and other wavelengths we cannot see, so the planet can glow in a language invisible to our eyes. It is a silent light show in a silent place, energy tracing invisible lines in a sky that looks smooth and calm in ordinary light. Uranus reminds us that reality depends on wavelength. The planet can look boring in visible light and still be active in signals we can only measure with instruments. The magnetosphere itself is like a restless bubble that never sits in one position for long. As Uranus rotates, the tilted magnetic axis sweeps through space, and the magnetotail can twist into a helical structure downstream in the solar wind, like a ribbon being wound and unwound. In a sense, Uranus is dragging an invisible sculpture through the darkness. Magnetic field lines stretched, twisted, and reconnected by the constant pressure of the sun's particle wind. The planet is not only rolling on its side, its magnetosphere is rolling too. The rings of Uranus were discovered not because they were bright, but because they caused a star to blink. That is such a gentle way to reveal something so real. A thin band of darkness showing itself by stealing light for a moment. Uranus's rings are narrow, dark, and made of particles that reflect very little sunlight. Their darkness is part of their personality. Saturn shows off with brilliant ice. Uranus hides its jewelry in charcoal, asking you to notice it only when you watch carefully enough to see a shadow move. The Epsilon ring, the brightest of the set, is still not bright in any Saturn sense. It is simply the most concentrated, most substantial ribbon in a system of faint lines. Its shape is maintained by two shepherd moons, Cordelia and Ophelia, which quietly herd material back into place. A ring is not only debris, it is an organized structure held by small gravitational hands. Uranus shows that even tiny moons can act like caretakers, maintaining a narrow band of order in a region where chaos would otherwise spread everything into haze. Sometimes Uranus's rings seem to vanish, not because they change, but because our perspective changes. When we see the rings edge on during a ring plane crossing, they become so thin that they nearly disappear against the background. The 2007 crossing offered astronomers a rare chance to see the system with reduced ring glare and to hunt for faint structures and moons that are normally drowned in the ring plane's clutter. Uranus teaches an elegant lesson. Visibility is not only about what exists, it is also about where you stand and the angle you're allowed to see. Beyond the sharper rings, Uranus also carries faint dusty components, including outer dust rings that are fed by tiny moons. Mab, for example, is linked to the outer Mu ring, supplying fresh dust when micrometeoroids strike its surface. In this way, the ring is not a dead leftover. It is part of an active cycle. Impacts create dust, dust spreads into orbit, and the Moon replenishes it again and again. Even in the cold outer system, destruction can be a form of creation. A tiny moon can paint a faint ring into the sky simply by being struck endlessly by the smallest bullets of space. The moons of Uranus are called the literary moons because their names come from Shakespeare and Alexander Pope, and that naming tradition fits the system's mood. Oberon, Titania, Ariel, Umbriel, Miranda, characters circling in silence. It is as if Uranus is surrounded by a cast, each moon playing its role in a slow cosmic drama, not acted by voices, but by gravity. Miranda is the strangest stage set of them all, a moon whose surface looks stitched together from incompatible pieces. It has abrupt boundaries between terrains, deep grooves, and strange ovoid regions that feel like frozen scars. Some theories suggest Miranda experienced intense heating in the past due to orbital resonances, cracking and rearranging its crust. Others imagine disruption and reassembly. Whatever the exact history, Miranda looks like a world that has been through something violent and survived. It is not smooth. It is a collage. One of Miranda's most famous features, Verona Rupes, is often described as possibly the tallest cliff in the solar system, though the exact height is uncertain and depends on how it is measured. Even the idea is enough to feel unreal. A scarp rising for many kilometers in a world where gravity is so low that falling would take minutes. The cliff is less like a drop and more like a slow release into darkness. Miranda turns vertical space into something dreamlike, showing that on low-gravity worlds, even a fall can feel like floating. Ariel often appears like the younger sibling among the major moons, with signs of resurfacing that softened older craters. It carries long valleys and trench-like structures that hint at crustal stretching and internal evolution. Ariel suggests that the Uranian moons may not all be equally dead inside. Some may have been warm enough in the past to reshape their surfaces, perhaps aided by tides and internal chemistry. Ariel feels like a moon that once moved, once flowed, once changed itself more recently than its darker neighbors. Umbriel is the quiet, dark counterpoint, the moon that looks like it rarely healed. Its heavily cratered surface suggests long periods without resurfacing. And yet it holds one unforgettable oddity. Wunder crater near the equator, with a bright ring on its floor that stands out like a pale halo. Its origin remains uncertain. Impact deposits, frost, or other material trapped in a basin. But the image is haunting. A dark moon with one bright circle, like a single eye open in a sleeping face. Titania, the largest moon, carries deep fractures and canyon systems that suggest its interior once expanded as it cooled and froze. Cracks and fault lines can form when internal layers change volume, splitting the crust like stressed ice. Titania's surface hints at a time when internal evolution mattered, when freezing and chemistry produced tectonic-like stress. It is a scarred queen, a large frozen world that remembers being active. Oberon, farther out, looks older and more heavily cratered, preserving impact history like a long memory. Some craters have dark floors, hinting at material that may have welled up or pooled after impacts. Its distance also means different exposure to space weathering and magnetospheric effects. Oberon feels like a relic, a cold archive of collisions, holding the record of ancient debris that shaped the moons. And now there is a fascinating modern twist. Hubble ultraviolet observations reported that the dark side patterns on some Uranian moons are not where scientists expected them to be. The outer moons, Titania and Oberon, show darker and redder leading hemispheres, consistent with the idea that dust from irregular moons coats the front-facing sides as they plow through space. This dust may act like a shield, with outer moons taking the brunt of the dust and protecting inner ones. It is a subtle kind of material exchange, a slow dust economy operating in silence across the Uranian system, showing that moons are not isolated. They share their environment. The irregular moons, distant, tilted, often retrograde, feel like captured strangers. Sycorax is the largest of these, and its reddish tint suggests radiation-processed material, like many outer solar system bodies. Caliban, Setebos, and others follow long, odd paths that hint at capture and fragmentation. Some may even be pieces of larger objects broken apart long ago. Uranus's outer moon region feels less like a tidy family and more like a swarm of old debris caught and held. Even Uranus can have temporary companions on its orbital road. A Trojan asteroid, 2011 QF99, was found sharing Uranus's orbit for a time, trapped in a gravitational pocket, but only temporarily on cosmic scales. It is a fellow traveler walking beside Uranus for a short chapter before drifting away again. In the solar system, companionship can be a matter of timing, not permanence. Voyager 2 remains the only spacecraft to visit Uranus up close, and its timing shaped Uranus's reputation. The planet looked smooth and calm, but later decades showed storms and activity as seasons shifted. It is a perfect example of how one snapshot can mislead. Uranus is not boring. Uranus is slow. Its changes happen on long timescales, and if you look at the wrong moment, you miss the movement. But if you watch long enough, the planet begins to reveal that it is alive with subtle dynamics. Uranus was seen before it was understood, and that makes its discovery feel even more like a slow awakening than a sudden surprise. Long before 1781, careful observers recorded the planet as if it were a faint, fixed star. John Flamsteed, for example, catalogued it in 1690 as 34 Tauri, because Uranus moves so slowly that over short spans it can hide among the background stars without revealing its wanderer's nature. It is a gentle reminder that the sky can hold a truth directly in front of us for centuries, and the only missing ingredient is recognition. Uranus existed in old notebooks as a quiet dot, waiting for the moment someone realized the dot was drifting. Because Uranus sits right on the edge of naked eye visibility, it is easy to understand how it stayed invisible to ancient civilizations, even if the planet was technically within reach. Under perfect dark skies it can be faintly seen, but it does not demand attention the way Jupiter does. It doesn't blaze. It whispers. Without telescopes, without careful charting, it blends into the quiet crowdedness of stars. Uranus teaches a subtle lesson about perception. Sometimes the limit is not what exists, but what stands out enough for a human mind to separate it from the background. Uranus is also unique in name as a planet. It is named directly from Greek mythology rather than Roman, a rare thread of language that survived into the modern map of the solar system. Uranus is the sky itself in myth, the primal dome above the world, and that choice feels fitting for a planet that often looks like a piece of sky, cut out and set adrift, smooth, pale, and distant. Even the name sounds airy compared with the heavier names of the other giants. Uranus is sky made into a planet, a reminder that humans have always tried to connect the heavens to story. If you look closely at Uranus's atmosphere, the simple cyan becomes a complex chemistry lesson. Methane sets the overall tone by absorbing red light, but in 2018, scientists confirmed another key ingredient high in the cloud tops: hydrogen sulfide, the same molecule that gives rotten eggs their smell. It's a funny image, but it matters because it distinguishes Uranus and Neptune from Jupiter and Saturn in cloud composition. It suggests the main cloud deck of Uranus is likely built more from hydrogen sulfide ice than from ammonia ice, telling a story about formation conditions and the ingredients available when the planet was assembled. Even a calm-looking planet can have sharp chemistry hidden in its smoothness. Over the last couple of decades, Hubble has watched Uranus long enough to prove that its calm face is not constant. A 20-year sequence of observations revealed that some things stay stubbornly steady, while others transform. Methane depletion appears to remain high in both polar regions across the observing period, like a persistent pattern that does not care which pole is facing the sun. But aerosols and haze do change dramatically with season, brightening and building up in the northern polar region as Uranus approaches its northern summer solstice. Uranus does not always change by making storms. Sometimes it changes by thickening a veil. This methane story has a fascinating detail. It is not uniform across the planet. Studies using Hubble and Keck data have found methane concentration can drop at high latitudes compared to lower ones, with significant depletion toward the poles. In simple terms, the poles can be drier in methane than the rest of the atmosphere, and this seems to persist even while other seasonal features evolve. It is as if Uranus has long-standing circulation patterns that remove methane from polar skies and keep it lower at gentler latitudes. The result is a planet whose chemistry is arranged in bands, not only its winds. The northern polar cap of Uranus has been brightening over time like a slow lamp turning up. Hubble images from the OPAL program have shown the polar region becoming more pronounced and hazy as the planet moves closer to northern summer. In 2007, near equinox, neither pole looked especially bright. Years later, the northern polar region began to thicken in haze and glow more strongly. Uranus doesn't do quick seasonal flips. It does decade-long transformations, like a planet slowly changing its makeup under faint sunlight. And yet, alongside these slow changes, Uranus can still surprise with sudden weather. Hubble images from 2014 and 2022 show multiple storms, bright methane ice clouds, appearing at mid-northern latitudes. Some storms have been large enough that amateurs could help spot activity, a rare moment where a distant ice giant becomes a shared skywatching event. These bright clouds are usually thought to be methane ice crystals forming when air rises and cools, like a cold weather version of convection. Uranus is quiet, but it is not inert. It is a world that sleeps lightly and sometimes rolls over. One of the most powerful reminders that Uranus is not done, surprising us, came very recently. In August 2025, astronomers announced that the James Webb Space Telescope discovered a tiny new moon orbiting Uranus, designated S/2025U1, only about 10 kilometers across. That discovery brought Uranus's confirmed moon count to 29. It's a tiny world, but it carries a big message. Even in a system we thought we had inventoried, there are still small bodies hiding in the glare near rings and inner moons. The Uranian system is not fully counted. It is still being revealed. Even the clock of Uranus has become sharper in the last couple of years. In April 2025, a long baseline of Hubble observations of Uranus's aurorae allowed scientists to measure the planet's rotation period with much higher precision, finding a day length of 17 hours, 14 minutes, and 52 seconds. This was slightly longer than Voyager 2's earlier estimate. It is a quiet kind of progress, not a new planet, not a new ring, but a more accurate truth about something fundamental: how fast the world turns. Uranus is a planet that still yields secrets even in the shape of a number. In July 2025, Uranus also gained a new kind of warmth in our understanding. NASA and collaborators reported that Uranus emits about 15% more energy than it receives from the Sun, resolving part of a long-standing debate about whether Uranus had essentially no internal heat. It still emits far less internal heat than Neptune, but it is not perfectly thermally silent. Uranus is quieter than its sibling, yet it is not empty. Even in the cold, there is a small inner ember. There is another modern twist to Uranus's magnetosphere story that makes the Voyager flyby feel even more like a single snapshot taken at the wrong moment. A reanalysis reported in late 2024 suggested Voyager 2 encountered Uranus during unusual solar wind conditions that compressed the magnetosphere dramatically, potentially skewing some conclusions about its plasma environment and particle belts. In other words, Uranus may have seemed stranger, or at least different in certain ways, because the Sun was in a rare mood when we passed by. This is one reason scientists keep saying we need to return. One flyby is a photograph, not a biography. Uranus's rings are a masterpiece of darkness, and the darkness itself is a clue. NASA and JPL have described the rings as reflecting only about 2% of the sunlight that hits them, making them among the darkest materials known in the solar system. This means the rings are not made of clean, bright ice like Saturn's. They are likely a mixture: ice plus dark, radiation-processed organics, coated and cooked by time and charged particles. Uranus's rings are not luminous ornaments. They are shadow jewelry, built from old debris and stained by the outer system's harsh weathering. The darkness is also part of why Uranus's rings can feel invisible even when they are there. They don't shine much invisible light, but in other wavelengths they can reveal themselves differently. Observations with ALMA and infrared instruments have imaged the rings by their own faint thermal glow, letting astronomers study cold particles not by the sunlight they reflect, but by the millimeter and infrared energy they emit. It is like watching a world not by what it shows you, but by what it quietly gives off. Even charcoal rings have a temperature, and in the cold outer dark, a faint heat can be a form of visibility. Uranus's rings also appear to be relatively young on a cosmic timescale, at least compared to the planet itself. Some models suggest parts of the ring system cannot be older than hundreds of millions of years, based on how shepherd moons and ring spreading would evolve. The implication is almost poetic. Uranus may not have worn these rings forever. It may have gained them later through collisions and breakups of moons. Destruction turned into structure. Rings, in this view, are not permanent jewelry. They are a phase, a moment in a system's life, when debris becomes a halo before it grinds down or gathers into something new. The ring particles themselves are not all dust. In fact, the system contains relatively little dust compared with Saturn. Many descriptions suggest much of the ring mass sits in larger chunks, from pebble-sized pieces up to boulder-sized bodies. This may be one reason the rings look narrow and sharp rather than bright and misty. A ring made of dust glows softly and spreads. A ring made of chunks looks like a thin line, a tight band of debris held in place. Uranus's rings are more like a gravel road than a fog bank. And if Uranus's rings are a dark halo, its moons are a quiet potential ocean family. In 2023, NASA/JPL modeling suggested that 4 of Uranus's major moons, Ariel, Umbriel, Titania, and Oberon, may still harbor subsurface oceans today, likely briny, trapped beneath ice. Miranda is probably too small to retain enough heat for a present-day ocean, but the larger moons may be ocean worlds in the hidden sense, not with surface seas, but with internal water kept liquid by long-term heating and antifreeze chemistry. It is a stunning reframing. Uranus may not just be a planet worth visiting. Its moons may be some of the most interesting hidden water targets in the solar system. If those oceans exist, the challenge is not poetry, it is detection. Scientists talk about using gravity measurements, magnetic induction, and careful tracking of how moons respond to tidal forces to infer liquid layers beneath ice. A mission that repeatedly flies past the moons could measure tiny changes in their gravity fields and magnetic responses, the way a doctor listens to a heartbeat to learn what's happening inside. Uranus's moons may be quiet on the surface, but inside they could hold movement. Slow water in darkness, circulating where no sunlight ever reaches. This is one of the reasons a return to Uranus has become a serious scientific priority. The Planetary Science Decadal Survey ranked a Uranus orbiter and probe concept as the top new flagship priority because Uranus is both underexplored and deeply informative. An orbiter could watch the planet through seasons, track storms and haze evolution, map rings in detail, study the strange magnetosphere properly under multiple solar wind conditions, and repeatedly visit the moons. A probe could taste the atmosphere directly, measuring noble gases and isotopes that reveal Uranus formed. One flyby gave us a snapshot. A flagship mission could give us a life story. Uranus also sits inside a quieter population of travelers that remind us the solar system is not neatly divided into planet space and empty space. Between the giant planets roam objects called centaurs, bodies that behave partly like asteroids and partly like comets, with unstable orbits that cross the paths of giants. Some centaurs can become active as they move inward, growing faint comet-like comas. They are transitional wanderers, refugees from the Kuiper Belt pulled inward by gravity. Uranus is one of the giants that helps sculpt their paths, either capturing them briefly, scattering them, or sending them onward. The emptiness between planets is not empty. It is a corridor of moving debris, slow and patient. Even the dark sides of Uranus's moons have become a new mystery. In 2025 reporting around Hubble, ultraviolet observations and conference discussions, scientists noted that some expectations about which hemispheres should be darker, based on magnetospheric particle interactions, did not match what was observed, especially for Titania and Oberon. One proposed explanation is dust shielding, where dust from impacts preferentially coats certain sides, altering brightness patterns. It is a reminder that moons do not live alone. They live in a dusty environment, in radiation, in a magnetosphere, in a subtle exchange of material. Their surfaces are not just old ice. They are canvases being slowly repainted by space. And through all of this, Uranus keeps its strangest signature. that sideways roll, turning seasons into decades of unbroken day and unbroken night. It is hard for the mind to hold that image without slipping into dream. 21 years of sunlight at a pole, then 21 years of darkness, the sun rising for a generation rather than a morning. That posture shapes everything. Winds, haze, storms, rings, even the magnetosphere's orientation to the solar wind. Uranus is not just a planet with seasons. It is a planet where the seasons are architecture. Uranus is surrounded by an atmosphere that fades into space so gently that it forms a vast hydrogen corona. Far above the visible cloud tops, the gas becomes thinner and thinner until it blends into the vacuum. But it doesn't end abruptly. Instead, Uranus wears an extended halo of hydrogen that can stretch out for several Uranian radii. It is the planet's quiet breath, a slow exhalation of atoms drifting outward, a reminder that the border between planet and space is not a wall. It is a soft gradient. And in that soft gradient, tiny particles can feel drag, as if even the emptiness has a faint touch. This hydrogen corona may even help explain why Uranus's rings have so little fine dust compared with Saturn's. In the thin upper atmosphere and extended exosphere, hydrogen can create enough gas drag to shorten the lifetime of very small ring particles, sweeping away the finest grains over time. It's a subtle idea, not a dramatic storm, not a collision, but a gentle, invisible friction that quietly clears out dust. Uranus doesn't just hold rings, it also slowly edits them, like a planet that can erase its own chalk marks in space. Uranus's upper atmosphere has been observed cooling over decades, and that cooling has a strange persistence that ignores the simple seasonal clock. Scientists track Uranus's ionosphere using infrared emission from H3+, a molecule that glows like a thermometer in the sky. Those measurements showed a dramatic cooling from the early 1990s into the 2000s, and later work found the cooling trend continued for more than 27 years, longer than the 21-year nominal season we often talk about on Uranus. It's as if the upper atmosphere follows a deeper rhythm than sunlight alone, reacting slowly to long-term changes in energy input and space weather. Uranus cools like a long breath leaving the body, not like a quick nightfall. Sometimes the most interesting Uranus facts are the ones that say, we still don't know why. The thermosphere is extraordinarily hot for such a distant planet, and at the same time the ionosphere has shown decades-long cooling. These two statements can sit together like a riddle, a hot upper layer, yet cooling trends over time, and no single explanation that closes the case. It is a reminder that Uranus is not simply cold. Uranus is complicated. It behaves like a system still negotiating how it exchanges energy with sunlight, with its own interior, and with the solar wind. Uranus's rings are not only thin lines. They are also full of fine structure, waves, ripples, and patterns that hint at unseen sculptors. Analysis of Voyager 2. Radio occultation data revealed quasi-periodic variations near the edges of the alpha and beta rings, and one interpretation is that tiny moonlets, only a few kilometers across, may be orbiting just outside those rings, stirring them the way a spoon stirs a glass of water. These moonlets would be too small and too dark to easily show up in Voyager images, yet their gravity could still write visible signatures into the ring edges. It's the classic Uranus theme, something too faint to see directly, revealed by the way it shapes a shadow. The dark color of Uranus's rings is itself a clue about their makeup and history. Measurements and models show ring particles can have very low reflectivity, bond albedo around 2%, meaning they absorb most of the sunlight that hits them. That darkness suggests they are not clean water ice like Saturn's bright rings. Instead, they are likely a mixture of ice and dark material, possibly organic compounds that have been processed and darkened by radiation over long spans of time. Uranus's rings are not a shining halo. They are a charcoal necklace stained by the harsh chemistry of space. Not all Uranian rings are the same kind of structure. Beyond the narrow main rings, astronomers found a pair of extremely faint, broad dust rings in the early 2000s, now called the Mu and Nu rings. These are not sharp lines. They are wide, soft belts, almost like misty lanes of dust. The brightest part of the Mu ring sits almost exactly on the orbit of the tiny moon Mab, which is why Mab is widely considered the source, its surface constantly supplying fresh dust when micrometeoroids strike it. Uranus has rings that behave like smoke, and a moon that behaves like the match. The Mu ring is a delicate reminder that ring systems can be alive, not frozen relics. Dust grains are constantly being created, constantly being pushed by radiation pressure and electromagnetic effects, constantly being removed or redistributed. In such a thin, dusty ring, the planet's shape, sunlight pressure, and the tiniest forces can matter. Uranus's outer dust rings are like breath on a cold window, visible, fragile, and always fading unless something keeps drawing them back again. Inside the ring region, Uranus has a crowded swarm of small moons that behave like an unstable neighborhood over deep time. Numerical studies of the inner satellites show that tiny gravitational tugs accumulate, and some orbital pairs are expected to cross on timescales as short as hundreds of thousands to millions of years, depending on assumptions, with collisions likely in the long run. Cupid and Belinda are often highlighted as especially unstable, and Cressida and Desdemona are another pair that can become risky over longer timescales. Uranus's inner system may be constantly rebuilding itself. Moons collide, debris becomes rings, rings spread, debris reaccumulates into moons again. The calm blue planet is surrounded by a region that evolves like slow-motion weather made of rock and ice. One of Uranus's small moons, Puck, was discovered just weeks before Voyager 2's closest approach, hiding until the last moment like a final character stepping onto stage at the end of a play. It is the largest of the inner moons, and one of the few we've actually seen as a real world with visible craters. Puck is dark, battered, and quietly important. It sits in the gap between the rings and the major moons, a bridge object in Uranus's crowded inner region. Even when we have images, Uranus's moons keep their details scarce, offering only hints of their true surfaces. Farther out, Uranus holds a different kind of moon story: captured outsiders. Sycorax, the largest irregular moon, was discovered in 1997 using the 200-inch Hale telescope at Palomar, and it likely did not form with Uranus. It orbits far away on a tilted retrograde path, like a stray world caught and kept. Sycorax is a reminder that giant planets do not only raise families, they also capture them. In the quiet outer solar system, gravity is a net that sometimes catches passing stones and turns them into moons. Those irregular moons may also be part of why the outer major moons show strange two-tone behavior over time. Dust and debris from irregular satellites can drift inward and coat other moons, preferentially darkening certain hemispheres. It's a slow dust economy, tiny grains migrating across the system over immense time, painting surfaces without anyone noticing in the moment. Around Uranus, space weather can be as literal as dust falling, grain by grain, through darkness. Uranus can even host a different kind of companion, not a moon, but a Trojan, a small body sharing the planet's orbit near gravitational balance points. The asteroid 2011 QF99 was the first confirmed Uranus Trojan, but it's not a permanent friend. It appears to be a temporary capture from the Centaur population, expected to stay near Uranus for tens of thousands of years before drifting away again. Uranus's companionship here is not a lifelong bond. It is a brief alignment, a shared walk through space before paths separate. The existence of a Uranus Trojan also ties Uranus to the strange family of objects called centaurs, small bodies that orbit between the giant planets and often cross the orbits of one or more giants. Centaurs are transitional wanderers, sometimes behaving like asteroids, sometimes showing comet-like activity, and they are typically unstable over long timescales. Their lives are shaped by gravitational nudges from planets like Uranus, which can scatter them inward, fling them outward, or briefly trap them into special relationships like Trojans or co-orbitals. Uranus is not only a planet, it is a gate and a sculptor for small bodies drifting between worlds. Chiron is one of the most famous centaurs, and its orbit lies between Saturn and Uranus, right in Uranus's wider neighborhood. For a long time, Chiron was treated like an odd asteroid, but later it showed comet-like behavior, and it became the namesake for the Centaur class. The region Uranus lives near is not a simple empty gap. It is a corridor of wandering ice and rock, a place where objects are slowly being moved, reshaped, and reassigned by gravity. Even in 2026, Uranus is still revealing new details, not because the planet changed overnight, but because our eyes got better. The James Webb Space Telescope has been powerful enough to detect extremely faint objects close to Uranus's ring system, including a tiny new moon candidate designated S/2025U1. If confirmed, it brings the known count to 29. What matters most for your script is not the number, but the feeling. Uranus is close enough to be familiar, yet still capable of hiding moons in the glare of its rings. The inventory of the solar system is not finished. It's just getting sharper. Some of the most important Uranus facts are not dramatic, but quietly foundational, like how much heat the planet releases. Recent work using modern modeling and spacecraft era data suggests Uranus emits about 15% more energy than it receives from the Sun. It is still far less internally active than Neptune, but it is not completely thermally silent. Uranus carries a small inner ember, a leftover warmth that may be trapped and released in complicated ways by layering and inhibited convection inside. It's a softer truth than no heat at all, and it makes Uranus feel less like a dead globe and more like a sleeping one. All of this points back to why Uranus is so often described as the great missing chapter of planetary science. We have seen Jupiter and Saturn up close for years with orbiters. We have watched their systems change in detail. For Uranus, we have one flyby and a handful of decades of telescopic watching. That's why the case for a dedicated Uranus orbiter and an atmospheric probe keeps returning. Uranus is not only strange, it is undersampled. A long mission would finally watch it breathe through seasons, watch its rings evolve, watch its magnetosphere change under different solar wind moods, and listen carefully enough to know which mysteries are real and which were just timing. William Herschel's telescope did not just find a new planet, it opened the door to a whole hidden family around it. 6 years after discovering Uranus, he also found its first 2 moons, Titania and Oberon. In 1787, tiny companions circling a sideways giant. Decades later, better instruments revealed more. Ariel and Umbriel were discovered in 1851, and much later, in 1948, Gerard Kuiper found Miranda. The timeline feels like a slow unveiling, as if Uranus allows new details only when our eyes become patient enough. Those 5 major moons were not named right away, which makes their story feel even more literary. The names Titania and Oberon, Ariel and Umbriel were assigned in the 1850s, drawing from Shakespeare and Alexander Pope, and the tradition continued until the Uranian system became a stage populated with characters instead of gods. It's one of the gentlest quirks in astronomy. A planet discovered by a man with handmade mirrors ends up surrounded by a cast of spirits and queens, as if the outer solar system became an endless theatre performed in silence. Like many large moons, Uranus's major satellites are tidally locked, which means they keep one face turned toward their planet almost all the time. If you could stand on Ariel or Umbriel, Uranus would hang nearly motionless in the sky, a pale turquoise giant that never truly rises or sets, only shifts slightly as the moon moves along its orbit. That kind of sky would feel dreamlike, one enormous world always present, as steady as a ceiling. It turns the moons into companions that are always watched, always facing their parent, like actors forever standing under a spotlight that never moves. Because Uranus is tilted so extremely, its moons orbit in a plane that is also tipped almost sideways relative to the Sun. The rings and most regular moons follow Uranus's equator, and since the equator itself is nearly vertical compared to the orbital plane, the whole system can look like a turned picture frame floating through space. In some seasons, sunlight hits the ring plane at a shallow angle, and shadows behave differently than on any other ringed planet. The Uranian system feels like a solar system inside a solar system, rotated 90 degrees, keeping its own orientation no matter how strange it looks from afar. Miranda, the smallest of the major moons, is often described as the most bizarre landscape in the Uranian family because it looks stitched together from different worlds. One reason is that Miranda has large oval regions called coronae, features with ridges and grooves that look like immense patches sewn onto the surface. They have names like Arden, Elsinore, and Inverness, again pulling from Shakespeare, and they make the moon feel like a quilt. Even without any heat today, Miranda carries the memory of internal stress, like a frozen bruise that never fully healed. Some of Uranus's moons carry a chemical mystery that feels like quiet snowfall made of carbon dioxide. Near-infrared observations have detected CO2 ice on Ariel, Umbriel, and Titania, concentrated mainly on their trailing hemispheres, the sides that face backward along their orbits. One leading idea is that charged particles from Uranus's magnetosphere strike those trailing sides more strongly, helping create or expose CO2 through radiation chemistry. It is a soft kind of violence, invisible particles painting chemistry onto ice over millions of years. What makes that carbon dioxide even more haunting is that it should not last easily forever. At the surface temperatures of these moons, CO2 ice is not perfectly stable on geological timescales, which suggests it may need replenishment, either by ongoing radiation chemistry or by occasional exposure of fresh material from below through impacts or slow surface processes. In other words, the moons may be quietly repainting themselves, maintaining a thin chemical frost not by weather, but by space itself. Uranus's ring system has an innermost member that feels like a ghost ring, the Zeta ring. It is a broad, faint structure discovered in Voyager 2 images and later studied again as Earth-based observations improved around the 2007 ring plane crossing. What's striking is that its structure appears to have changed over time, as if dust shifted, spread, or was replenished in the decades between snapshots. The Zeta ring reminds us that rings are not static jewelry. They can evolve like weather, slowly, quietly, without anyone noticing until the next time we look. That same Zeta ring is also a reminder that faint does not mean simple. Re-analyses of Voyager data suggest its brightness changes with viewing angle in a way consistent with extremely small particles on the order of sub-millimeter grains. For future missions, that matters, because tiny dust can still be a navigational hazard if you pass through the wrong region. In the outer solar system, even a whisper of dust can become an engineering question, and Uranus's faintest ring becomes a real factor in how we plan to return. Voyager also detected extremely faint sheets and dusty structures inward of the brighter rings, features that were so subtle they were easy to dismiss until later reanalyses found them again. Some of these components appear more like a thin fog than a line, a diffuse veil of particles drifting in the same plane as the rings. It's the kind of detail that makes Uranus feel layered, not just rings, but gradients, not just moons, but a whole disk of debris in different densities, like a system that never fully cleared its own clutter. Uranus's magnetic environment has another seasonal trick, even stranger than its seasons of sunlight. Because the planet is tipped over, the orientation of its spin axis relative to the solar wind changes dramatically across its year, from configurations where it is almost perpendicular at solstice to configurations where it becomes much more aligned near equinox. That means the way the solar wind hits Uranus's magnetosphere is seasonally different in geometry, not just in strength, which can reshape the magnetotail and plasma environment in ways that are still being modeled. In simulations of Uranus at equinox conditions, researchers have explored how the magnetosphere might behave when the solar wind direction and the planet's odd magnetic tilt combine into a different alignment than at solstice. The outcome is a magnetosphere that can look like a constantly shifting sculpture, field lines stretching and reconnecting, flows changing direction, and the tail responding to rotation like a slow corkscrew. Uranus is not just a planet with a weird magnetic field. It is a planet where the magnetic story changes with season. Even the shape of Uranus is a quiet clue to its fast spin. Like the other giants, it is an oblate spheroid, slightly flattened at the poles and bulged at the equator, because rotation pulls material outward. If you could measure Uranus with a perfect caliper, you would find the equatorial Uranus is a little wider than the polar Uranus, a subtle distortion that makes it feel less like a perfect marble and more like a spinning fruit. It's a gentle reminder that rotation is not only time, it is a force that shapes the silhouette of worlds. Uranus is also a planet where the definition of north can quietly confuse the mind. By one convention, Uranus rotates backward compared with most planets because its spin axis is tipped past 90 degrees. Depending on how you define the pole, you can describe its rotation as retrograde, and the result is that compass directions in Uranus's sky can feel inverted. It's a small conceptual twist, but it fits Uranus perfectly. Even the directions feel like they've been turned sideways with the planet itself. There is something soothing about how Uranus's biggest mysteries are not explosive. They are structural. Why is its internal heat so modest compared with Neptune's? One leading family of ideas involves layering inside the planet. If the interior is stratified like a stable layer cake, convection can be inhibited and heat can be trapped or released inefficiently. In that picture, Uranus is not dead, just internally quiet. A world where the deep mixing that powers other giants is muted, leaving the outer atmosphere calmer and the planet's glow fainter. Uranus sits in a region of the solar system that is full of in-between travelers, and this gives it a quiet role as a shaper of wandering objects. Centaurs roam between the giant planets on unstable orbits, sometimes becoming active as they drift inward. Over long time, Uranus can scatter them, redirect them, or briefly trap them into special configurations. It is a gentle kind of guardianship, not like Jupiter's dramatic gravitational dominance, but a steady reshaping of paths in the cold outskirts, guiding small bodies through the corridor between worlds. Uranus's ring system may also be younger than the planet itself, which suggests a story of recurring renewal. If rings spread, grind down, or are cleared on timescales shorter than the age of the solar system, then what we see now could be the product of more recent breakups, moons drifting too close, collisions among small satellites, or debris released and then sculpted into narrow bands. In that sense, rings are not an ancient crown. They are a phase, something a planet can gain, lose, and regain, like a necklace made and remade from the same old stones. The 5 major moons together also form a quiet set of ocean world possibilities. Models and reanalyses in recent years have suggested that Ariel, Umbriel, Titania, and Oberon could plausibly harbour subsurface oceans today, likely salty and trapped beneath thick ice, while Miranda is probably too small to retain such heat. If true, Uranus would not be one mystery, but several. A planet wrapped in haze and a family of moons wrapped in ice, each potentially hiding liquid water in darkness. And finally, Uranus is a planet that keeps reminding us that a single flyby is not enough. We met it once up close, under one set of solar wind conditions, at one season, from one angle. Since then, the planet has been quietly changing. Haze building, storms appearing, faint structures being detected in rings and dust, and even new small moons being found or proposed. Uranus is not the kind of world that reveals itself in a single glance. It reveals itself the way its seasons move, slowly, patiently, over decades. As our eyes become sharper and our listening becomes more careful. And so our journey through Uranus comes to a gentle close. We have drifted through its dark rings and faint dusty belts, watched the seasons paint polar hoods across a tilted sky, and wandered among moons named for poets and plays. We have imagined storms blooming quietly in infrared light and listened to the planet's magnetic strangeness without ever hearing sound in the vacuum. Uranus remains a sleeping giant only in appearance, a pale, sideways world that keeps its secrets in soft cyan light, waiting at the edge of the sun's warmth. If you happen to still be awake, that's perfectly all right. You can simply lie back, let the music keep flowing in the background, and drift in and out of the story at your own pace. But if your eyes are heavy, let the stories of this sideways world and the gentle music carry you softly into rest. Sleep well. Good night.